In this video, we're going to see how we can schedule a demand response or an energy service in this platform. Let's start with PeakShaving. So for PeakShaving, you click on the plus button and you'll be immediately prompted with a form to input the information you need to set up this service. Let's start with a PeakShaving limit of 200 kilowatts, and let's set it up for 10 a.m. in the morning until 12 p.m. in the afternoon. We click here as a recurring schedule and we hit save button. Now we wait to see immediately the service appearing in the 24-hour forecast, and what you can see here is the white line showing the limit where we expect to see the grid power to be up to this point. And the forecasted information of the grid power, instead of actually being at 526, it's estimated to be at 200 kilowatts for the time period that we have set it to be. And for that to be achieved, we need to provide that extra amount of energy that we are shaving with our watts battery modules. And this estimated amount of energy is shown in this graph with the green dotted line. However, because we want to see this action in real time, we're going to set up another schedule, which will be at this corresponding time to visualize the behavior. So we continue with 200 kilowatts, and now we know that it's almost 5:10 in the morning. Let's try to put it at this time. 5, put it at 9 minutes, so I will see it immediately in action, and we set it to finish after a few minutes of operation. Oops. Put at 12. Okay, that's it. So we click save, and now we will go up in the real-time information, and what we expect to see is a similar behavior to this one here, where we see the grid power reducing, and at the same time we see the battery power increasing to supply that extra power that we're requiring. Now immediately what we can see here is that we reached 5.9, and in a fraction of seconds we can see the response kicking in. Now we see the grid going close to 200 kilowatts, but never above that, and the amount of shaved power, we are now covering it with watts battery modules. And if we scroll a bit further up, we can start seeing the operation of the watts battery modules and how this is affecting the information we see in the status of the network. Now we can see that 155, 56 kilowatts is already supplied by watts battery modules. This accounts to around 10% of the available max power that we have in the network. And the consumption, which is around 338 kilowatts, is now shared between the grid and the watts battery modules. We have almost 45% of this energy coming from the watts battery modules. So the amount of energy that we now try to shave is provided by watts battery modules, so we don't need to impact the operation of the customers being supplied with energy. So let's go back into the real-time information and real-time statistics here, and we will be waiting to see the behavior of the PeakShaving ending by 5:12. So now we're reaching 5:12 a.m. and it's a pause for our schedule to stop. And what we can see now is that immediately the power from the grid is increasing back to the normal state because we are now don't have any energy service active at this corresponding time. In the same time, we see immediately the watts battery module's power reducing to 0, and we are seeing the exact information that we have seen previously. So we can see exactly here that the load was always stable. We never reduced the load consumption in the network because we were always supplying that energy that we have shaved with watts battery modules. However, we have influenced the behavior of the grid, and we were able to reduce this amount significantly with the peak shaving information, that a peak shaving schedule that we have provided with our platform.